These are examples for section 10.2, special right triangles. Before we can use the special right triangles ratios, we reviewed some Algebra 1 rationalizing denominators. Recall that rationalizing denominators is necessary when anytime you have a square root in a denominator like this. You're never supposed to leave that in the denominator. So if we have 2 over the square root of 6, the way we can get rid of this square root of 6 is by multiplying this entire fraction by 1. But the 1 needs to be in the form of the square root of 6 over the square root of 6. Anything over itself is equal to 1 whole, and when you multiply 1 by anything, it doesn't change the value of it, so we can get by with this. The reason why we chose the square root of 6 over the square root of 6 is because the denominator is already the square root of 6, and when we multiply the square root of 6 times the square root of 6, we're going to get the square root of 36, and the square root of 36 gives us just simply 6, so we do get rid of the square root. Again, when we multiply two fractions, we multiply the numerators, 2 times the square root of 6. Remember, you never multiply rational with irrational numbers. This is how you have to write it. Over the square root of 6 times the square root of 6 is the square root of 6 times 6. That gives us 2 times the square root of 6 over the square root of 36. And the square root of 36 is 6. 36 is a perfect square, so we get 2 times the square root of 6 over 6. And then always make sure, if you can, reduce further any rational or irrational parts. 2, 6 reduces by 2. 2 goes into 2 once, 2 goes into 6 3 times. And then we get 1 times the square root of 6 over 3, or simply the square root of 6 over 3. Now you try practice 1. Simplify 1 over the square root of 5. Pause the video, and when you're ready, turn it back on. Practice 1. Simplify 1 over the square root of 5. We must rationalize this because there's a square root in the denominator. So 1 over the square root of 5, we multiply by a form of 1 as the square root of 5 over the square root of 5. Multiplying the numerators together, 1 times the square root of 5 is 1 times the square root of 5 over the square root of 5 over the square root of 5 times the square root of 5 is the square root of 5 times 5. And so we get the square root of 5 over the square root of 25. 25 is a perfect square, so the square root of 25 is 5. So we have the square root of 5 over simply 5. And that is the rationalized or simplified equivalence to this. Remembering the rationalization of denominators rule in algebra, we can solve equations, or proportions, which are equations, dealing with square roots. Here we have solve and simplify 2 is to x as the square root of 3 is to 6. We can cross multiply or use cross products here because we have a ratio equals a ratio, or fraction equals fraction. So when we start cross multiplying, if we cross multiply this way, we get x times the square root of 3 equals 2 times 6 is 12. Just as we get rid of any coefficient of x, like 3x, we get rid of the square root of 3 that's being multiplied with x by dividing both sides by the square root of 3. The square root of 3 over the square root of 3 divide out, and we're left with x. And here we need to rationalize 12 over the square root of 3. So to get rid of the square root in the denominator, we multiply by a form of 1, the square root of 3 over the square root of 3. 12 times the square root of 3 is 12 times the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9. And then that's 12 times the square root of 3 over the square root of 9 is simply 3. 12 thirds reduces by 3. And so we get 4 times the square root of 3 for our value of x. So 2 is to 4 root 3 as root 3 is to 6. Anyway, your answer is x equals 4 times the square root of 3. Now you try practice 2. Pause the video. When you're ready, turn it back on. Practice 2. Solve and simplify. The square root of 2 is to 5 as 1 is to x. Since we have a proportion equation, we can cross multiply. Cross multiplying this way, we get x times the square root of 2. Cross multiplying this way, 5 times 1, or 5. Dividing both sides by the square root of 2 so that we can get x by itself. The square root of 2 divide out here, and we're left with simply x. Here we need to rationalize the denominator because of the square root, so we multiply by a form of 1 as the square root of 2 over the square root of 2. 5 times the square root of 2 is 5 root 2. Square root of 2 times square root of 2 is the square root of 4. So x is equal to 5 times the square root of 2, and the square root of 4 is simply 2. 5 halves does not reduce, and unless otherwise told, leave this as a fraction, an improper fraction. Don't take your calculator and divide it unless the problem asks you to. So the answer is 5 root 2 divided by 2, or 5 root 2 over 2. Root 2 is to 5 as 1 is to 5 root 2 over 2. Many times with equations or proportions, when we cross multiply, we end up having to multiply two radicals together. Example 3, solve and simplify. The square root of 2 is to 2 as x is to the square root of 3. Since this is a proportion, we can cross multiply. So I cross multiply this way, I get 2x. Cross multiply this way, I get the square root of 2 times the square root of 3. This gives us 2x equals, putting everything underneath one radical, I have the square root of 2 times 3. Simplifying that, I get 2x equal the square root of 6. Then getting rid of the 2 coefficient, I divide both sides by 2 to solve for x. The 2's divide out, and x is equal to the square root of 6 over 2. This does not need to be rationalized because there's no square root in the denominator, so this is your answer. Square root of 2 is to 2, as square root of 6 over 2 is just the square root of 3. One last thing. Always check your radicand to see if it will simplify at any point in the problem. So far they have not simplified. The square root of 6 does not simplify. 6 is not a perfect square, and it doesn't have any perfect square factors. Now you try practice 3. Solve and simplify the proportion 4 is to root 10 as root 2 is to x. Be careful. Pause the video. When you're ready, turn it back on. Practice 3. Solve and simplify 4 is to the square root of 10 as the square root of 2 is to x. Another proportion we can cross multiply, so I have 4 times x, or 4x, equals the square root of 10 times the square root of 2. This gives us 4x equal the square root of 10 times 2. Put it all underneath one radical symbol. This gives us 4x equal the square root of 20. Divide both sides by 4 so we can solve for x. The 4's divide out over here, and we get x equal the square root of 20 over 4. Now this does not rationalize, but you're still not finished because the square root of 20 will simplify. 20 is not a perfect square. However, it does have a perfect square factor. The factors of 20 are 2 times 10 and 4 times 5, and 4 is a perfect square. So this would be the square root of 4 times 5 over 4. Splitting those up, we have the square root of 4 times the square root of 5 over 4. And then the square root of 4, that being a perfect square, gives us 2. The square root of 5 does not simplify, so we leave that over 4. And then finally, 2/4 reduces by 2. 2 goes into 2 once, 2 goes into 4 twice, and we get the square root of 5 over 2 is the value of x. As you can see, sometimes your simplification goes on quite a bit, so make sure you completely simplify when you solve with radicals. One last type of problem dealing with radicals and equations is the following. Example 4. Solve and simplify 6 is to x as x is to 3. Now you've done some of these before, so this shouldn't be any a new thing, but we cross multiply as before, so I'm going to cross multiply this way. I have x times x. equals 6 times 3. X times x gives us x squared equals 6 times 3 is 18. Since we're solving for x, we need to get rid of the squared on the x, so we do the inverse operation, which is to take the square root. We have to do it on the other side to balance the equation, so the square root and the square cancel each other out, and we're left with x equals the square root of 18. Check to see if 18 will simplify into the square root, which it does. Not only does it have the factors of 6 times 3, in which both of those are not perfect squares, it also has the factors of 9 times 2, in which 9 is a perfect square. So we split that up into 9 times 2, factor it, and then we split it. Square root of 9 times square root of 2, and 9 being a perfect square gives us the square root of 9 is 3 times the square root of 2. So 6 is to 3 root 2 is 3 root 2 is to 3. When given a right triangle and looking for one of the side lengths, if you're given 2 of the 3 right triangle sides, you can always use Pythagorean theorem. However, if you're only given one side of the 3, like this problem, then many times you can use one of the new theorems that you learned, the 45-45-90 triangle theorem or the 30-60-90 triangle theorem. These are special right triangles, and their sides have specific ratios. So make sure you've studied those before you attempt examples 5 through 9. Example 5. Find the exact length of the missing side length of the following triangle. Actually, there's 2 side lengths here, but these 2 side lengths are going to be the same because they have tick marks in them. So I'm going to call this x, and therefore that has to be x also because they're the same length. Now, to determine which ratio or which special right triangle we have here, sometimes you have to look a little closer. Since these 2 sides are congruent, it's an isosceles triangle, and by the isosceles triangle theorem, the angles opposite those sides are congruent. And since we have a right triangle and these 2 angles are congruent, this being 90 degrees, these 2 angles together have to add up to 90 degrees, so that when 90 and 90 are added together, we get 180, triangle angle sum theorem. Since these both have to be the same and split between 90 degrees, then 90 degrees divided by 2 is 45 degrees. So this is a 45-45-90 right triangle. And before you can solve the problem, you have to at least be aware of that. Since it's a 45-45-90, we use the 45-45-90 triangle theorem, which says that the short leg to the long leg, not the short leg, just the leg. One of the legs is to the other leg is to the hypotenuse. Ratio is 1 to 1 to the square root of 2. And the way I taught you how to do this is you create ratios out of all 3 of these ratio numbers, where these are all the first terms. And the bottom terms here are used with the sides over here. The hypotenuse is given to us, which is 8. The hypotenuse is represented by the square root of 2, so we put 8 underneath it. To create the ratio, root 2 is to 8. Then we come over here to one of our legs. Since both legs are the same in a 45-45-90, it doesn't really matter which one we use because they both have 1 represented in the ratio. So I'll just choose this one because it's closest in proximity here. But it's x. We don't know what it is, so I'm going to put an x there. Now all we need to do is use these 2 in a proportion. 1 is to x as, change the colon to an equal sign. The root 2 is to 8, and solve for x. Cross multiply, we get x times the square root of 2 equals 1 times 8 is 8. Divide both sides by the square root of 2. The square root of 2's divide out there, and x equals, we need to rationalize this by multiplying by a form of 1, root 2 over 2. 8 times the square root of 2 is 8 root 2. The square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is simply 2. 8 halves reduces by 2. 2 goes into 2 once, 2 goes into 8 4 times. And so now we have simply x is equal to 4 times the square root of 2 over 1, or simply 4 root 2. So x, the length of these two legs, both are 4 times the square root of 2 units long, if this is 8. They wanted the exact length, so we do not approximate this, unless you just want to check it. Practice 5 is very similar to example 5. Try practice 5, pause the video, and then turn it back on when you're ready. Practice 5. Find the exact length of the missing side length of the following triangle. And we have, again, 45, 45, 90 here. Since these two sides are congruent, the angles opposite them are congruent, and since those are congruent and this is a right angle, these together have to be 90, and therefore both of them have to be 45. So this is a 45, 45, 90, and I'm going to call this x. These are the same variable because they're the same length. So we use the ratio for the 45, 45, 90 triangle theorem, which is 1 to 1 to root 2. Create ratios out of them. 10 is the hypotenuse, so the 10 goes underneath the third number, root 2. X, we can either use this one or this one because they're the same. I'll use this one. Create a proportion out of this. 1 is to x, as root 2 is to 10. Cross multiply. We get x times the square root of 2 equals 1 times 10 is 10. Divide both sides by the square root of 2. Square root of 2's divide out there. We need to rationalize this because of the square root in the denominator, so we multiply by the square root of 2 over the square root of 2. 10 times the square root of 2 is 10 root 2. Square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is simply 2. One last step, we need to simplify 10 halves. 10 halves reduces by 2, 2 goes into 2 once, 2 goes into 10 5 times, so we simply have x equal 5 times the square root of 2. That's that value and that value. Example 6. Find the exact value of both missing side lengths of the following triangle. Here we have a right triangle with a 60-degree angle. Because this is 60 degrees, this has to be 30 degrees because of the triangle angle sum theorem. 90 plus 60, subtract from 180, you're going to get 30. So this is a 30, 60, 90. So by the 30, 60, 90 triangle theorem, the ratio of short leg to long leg to hypotenuse is 1 to the square root of 3 to 2. So 1 represents the short leg, root 3 represents the long leg, and 2 represents the hypotenuse. 1 to root 3 to 2. Following the same pattern we did with the 45, 45, 90, we take a look at our triangle and look and see where we have a given measurement, and it's on our longest leg. We know for sure it's the longest leg because it's across from the largest angle, 60 degrees. So if you're ever wondering if the two sides are real close together in length, visually, always look for the angles and go across to the opposite side to see which one's smaller and which one's larger. So this would be the long leg, so the 4 would have to go underneath the ratio number representing the long leg, which is the square root of 3. So I put the 4 there. The short leg is x, so I put it underneath the 1. And the hypotenuse is y, across from the right angle, goes underneath the 2. Once we've set this up, this yields two separate proportions. This is the ratio that has numbers for both terms, so we're going to use it twice in both proportions. So I'm going to use this one and solve. Then I'm going to use this one and solve. This one's for our x, this one's for our y. Cross multiplying here, we get x root 3 equal 1 times 4 is 4. divide both sides by root 3. Square root of 3's divide out there, and x is equal to, after rationalizing this, we get 4 root 3 over root 3 times root 3 is root 9, and the square root of 9 is 3. For this proportion, cross multiply, we get y root 3 equals 4 times 2 is 8. Divide both sides by the square root of 3. Those divide out, rationalize to get rid of the square root over here in the denominator. Y is equal to 8 root 3 over the square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3 again. So x is 4 times the square root of 3 over 3, and y, the hypotenuse, is 8 root 3 divided by 3. These are exact lengths. These are not approximations. Practice 6. Find the exact length of both missing side lengths of the following triangle. Try this practice problem on your own. Pause the video, and when you're ready, turn it back on and check your answer. Practice 6. We have a right triangle here, of course, and we've got a 30-degree angle. Therefore, this angle has to be 60 degrees by the triangle angle sum theorem. 90 plus 30 plus 60 is 180. So in a 30, 60, 90, by the 30, 60, 90 triangle theorem, we have the ratio of short side or short leg to long leg to hypotenuse as 1 to root 3 to 2. We're going to create ratios out of all three. Taking a look at our triangle, the longest leg is the one with 9 on it because it's opposite the largest angle. So the longest leg goes under the square root of 3, so this would be 9. The hypotenuse is y, across from the right angle, so it goes under the 2, and the x is the shortest leg, so it goes under the 1. Again, we're going to solve two separate proportions, that one and that one. For this first one, 1 is to x as root 3 is to 9. Over here, we're going to have root 3 is to 9 as 2 is to y, and solve both proportions. Cross multiplying this way, we get root 3, x root 3 equal 9. Dividing both sides by root 3, those divide out, and x is equal to, after rationalizing because of the square root in the denominator, once again, 9 root 3 in the numerator. Root 3 times root 3 is root 9. Root 9 is simply 3. Did you simplify 9 thirds? 9 thirds reduces by 3. 3 goes into 3 once, 3 goes into 9 3 times. So x is simply 3 times the square root of 3. For y, cross multiply, and we get y times the square root of 3 equal 9 times 2 is 18. Divide both sides by the square root of 3 to get rid of this square root of 3. 18 over the square root of 3 needs to be rationalized because the denominator has a square root in it. So we multiply by a form of 1, square root of 3 over square root of 3. 18 times square root of 3 is 18 root 3. Square root of 3 times square root of 3 is square root of 9, and the square root of 9 is simply 3. 18 thirds reduces by 3. 3 goes into 3 once, 3 goes into 9 6 times, and so y is equal to 6 root 3. So x is 3 times the square root of 3 units long. The long leg was 9 units long, and the hypotenuse is 6 times the square root of 3 units long. These are exact answers. We can use these new theorems on special right triangles to solve various kinds of problems. Don't forget to always try to use Pythagorean theorem if you can. Sometimes you can, sometimes you can't. I'm going to focus in on using these new theorems over the Pythagorean theorem, though. Example 7. Find the exact perimeter and area, these are exact, of the square that's given to you if one of its diagonals measures 6 inches in length. Well, there's no diagonal drawn, so let's draw one. I'm going to draw this one from this vertex in the upper right hand corner to the lower left hand corner. I'm going to dash it in and label it with 6 inches. Well, it just told us that this was a square, and that one word's powerful. It tells us not only that all the sides are congruent, but it also tells us that all the angles in the polygon are right angles. So it doesn't really matter which one you take, this one or that one. If we can find the length of one of the sides, we can find the perimeter and we can find the area of it. Remember, recall that the perimeter formula for a square, you can use 2L plus 2W, but it's simpler to use 4 times the length of a side. And the area formula for a square, you can use length times width, but it's simpler, I think, if you use A equals side squared. So we'll use those at some point. But to find one of the sides, notice that the diagonal creates two 45, 45, 90 triangles. I'm just going to focus in on this bottom one here. We know that these are congruent, so I'm going to call that S for side and that S for side, both the same. And so we have a 45, 45, 90, so our ratio using the 45, 45, 90 triangle theorem is 1 to 1 to root 2, leg to leg to hypotenuse. Take a look at the triangle. Our hypotenuse is 6, so we place the 6 underneath in our ratio, underneath the square root of 2. And then S, we can either place here, here, or both. It doesn't really matter. I'm just going to use this one. Now I have a proportion all ready for me to set up. So I'm going to write the proportion. 1 is to S equals, change the colon to equal sign, square root of 2 over 6. Cross multiply, we get S times the square root of 2 equal 1 times 6 is 6. Divide both sides by the square root of 2. Those divide out. Over here we need to rationalize once again. The square root of 2 over the square root of 2, form of 1. We get S is equal to 6 times the square root of 2 is 6 root 2. Square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. 6 halves reduces by 2. 2 goes into 2 once, 2 goes into 6 3 times. So we get a side length of 3 times the square root of 2 inches, because they give us inches up here. So there's our side length. They asked specifically for the perimeter and the area. So starting with the perimeter. Perimeter of a square, again, is 4 times the length of a side. And the side here we found is 3 times the square root of 2 inches. When you multiply rational and irrational numbers together, remember, you can only multiply the rational parts together. So 4 times 3 is 12 times the square root of 2 inches. So the perimeter all the way around this square is 12 times the square root of 2 inches. For the area, we have side squared from our formula. So we take the length of a side and we square it. So we take 3 root 2 inches and we square it. Now when you square rational and irrational numbers and even units, you square everything inside the power rule from last year in Algebra 1. So this would be 3 squared times the square root of 2 squared and then times inches squared. And this makes sense because you know that area is always measured in square units. So this took care of that. Then you simplify. 9 squared, 3 squared is 9, times the square root of 2 squared is the square root of 2 times the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. So let me write that here. And the inches squared just tags along now. And then finally, 9 times the square root of 4 is 2 inches squared, and 9 times 2 is 18 square inches. So the area of this square is exactly 18 square inches. And that makes sense when you think about it, because since the diagonal is 6, but anyway, it's 18. So all the square inches, if you were to line all the squares up that are inch by inch by inch by inch, there would be a total of 18, exactly 18 of them. Example 8. The given triangles are similar. The longer leg of the larger triangle measures 33 yards. So here's the larger right triangle than that one. So this is 33 yards all the way up to there, all the way down to here. And the smaller triangle, the longer leg of the smaller triangle, measures 21 yards. So from here down to here is 21 yards, all the way down, all the way up to there. Find the exact values of x and y. We want exact values. And then how much longer is the larger triangle's hypotenuse? So we want to know how much longer this hypotenuse is compared to this hypotenuse. Alright, so starting off with we have the small triangle and the larger triangle. And we'll worry about their difference later. These are both 30, 60, 90 triangles, because since this is 30 degrees, this has to be 60. And because this is 60 degrees in this right triangle, this has to be 30. So we just got to be careful, what goes where. Our ratio for 30, 60, 90, using that theorem, is 1 to root 3 to 2. So again, 1 to root 3 to 2. Remember, this is short leg to long leg to hypotenuse. We're going to create ratios out of these. Starting with the smaller triangle, we have the hypotenuse is x. The hypotenuse is represented by the 2. And the long leg they gave us is 21 units long, or 21 yards. So the long leg underneath the square root of 3 is 21. And we're not even going to use this one, so we can just leave it off. Then over here on the larger triangle, we have the hypotenuse is y, so it goes underneath the 2. And the longer leg is 33 yards. That's the longer leg. So that would go here under the square root of 3. We're not going to use that one. So we're going to have two separate proportions solved. So we have the square root of 3 is to 21 as, or equal to 2 over x. And over here we have the square root of 3 is to 33 equals, or as, 2 is to y. Now cross multiplying here, we get the square root of 3, x times the square root of 3 equals 21 times 2 is 42. Divide both sides by the square root of 3. Those divide out. We need to rationalize this. Square root of 3 over the square root of 3. We get 42 times the square root of 3 over 3. Then when we simplify, 3 will go into 42 evenly. It goes 14 times. So 3 goes into 42 14 times. 3 goes into 3 once. 14 times the square root of 3 over 1 is simply 14 times the square root of 3. And this is in yards. So the length of this hypotenuse right here is 14 root 3 yards. Then coming over here to the larger triangle, doing the exact same thing, just with different numbers, we have y root 3, y times the square root of 3, equal 33 times 2 is 66. Divide both sides by the square root of 3. Those divide out. Need to rationalize over here because of the square root in the denominator. We get 66 root 3 over 3. 66 thirds reduces by 3. 3 goes into 3 once. 3 goes into 66 22 times. So y is equal to 22 times the square root of 3 over 1, which is simply that. So y over here is 22 times the square root of 3. Now how much longer is this hypotenuse than this one? This will be a good review on how to add and subtract radicals, which we haven't really talked about much. Well, we're going to subtract this hypotenuse from this one. So we're subtracting x from y. Well, y is 22 times the square root of 3 minus x is 14 times the square root of 3. Use the distributive property. Kind of like these are variables. The square root of 3 and the square root of 3. Since they're exactly the same, we can subtract these. If this had been, let's say, the square root of 3 and this was the square root of 2, we wouldn't be able to subtract these and to simplify it. So anyway, use the distributive property. Factor out the square root of 3. And you have 22 minus 14 left. And then 22 minus 14 gives us, what is that, 8 times the square root of 3. So the difference between the hypotenuse lengths here is 8 times the square root of 3 yards. And so this one is 8 times the square root of 3 yards longer. Example 9. A jet takes off and climbs at a constant 30-degree angle until the jet has traveled 13 miles across the state. At that point, what is the jet's altitude, height up in the air, rounded to the nearest tenth of a mile? So we're going to find an approximation. And then exactly how far has the jet traveled into the air? So how far it's traveled into the air would be the length, this hypotenuse length. I'm going to use D for that, A for altitude. Let's start with the altitude though. This is a 30, 60, 90 because measuring the height the plane is, or the altitude, means that automatically it's perpendicular to the ground. So we have a 30-degree angle here because it said it climbed at a 30-degree angle, so this has to be 60 degrees over here. Triangle angle sum theorem. So a 30, 60, 90 gives us the proportion 1 to root 3 to 2. And we're given how many miles across the land it's traveled, so this would be the longer leg across from the 60-degree angle. So underneath the square root of 3, I put a 13. Then for A, this would be the short leg, so we put an A here. If you want to, go ahead and put D over here. There's a couple of ways you can do this. Anyway, I'm going to take these two first because we're looking for the altitude. So we have 1 is to A as root 3 is to 13. Cross multiply, we get A root 3 equal 13. Divide both sides by root 3. Rationalize. Those divide out, and A is 13 root 3 over 3. 13 thirds doesn't reduce. Now we need an approximation, so in your calculator, what you can do is put in 13, and then immediately second square root 3, close parenthesis, make sure you close parenthesis, divide by 3, enter. We get about 7.5055553499 and so forth. It's 7.5 rounded to the nearest tenth of a mile. So we have 7.5 miles about up in the air. So the altitude of that plane is about 7.5 miles, 7.5 miles up in the air. Now, for the distance it's traveled into the air, the literal distance from this point to its new point here, we're going to use these two. So I'm going to bring these over here. That's root 3 is to 13 as 2 is to D. Cross multiply, we get D times the square root of 3 equal 13 times 2 is 26. Divide both sides with the square root of 3. We need to rationalize. Those divide out. 26 times the square root of 3 over 3. 26 thirds does not reduce. So we take our calculators. We want an approximation rounded to the nearest tenth. See if you can do that. And don't forget your closing parenthesis. And we get about 15.011107, so forth. So about 15.0 miles. So the jet has traveled so far 15 miles into the air. This distance was how far it traveled across the land. So make sure you can distinguish between those two.